Hello, this is John from caveofprogramming.com. In this tutorial we're going to look at allocating memory in C++. We've already seen in this course some ways of allocating small amounts of memory by declaring a variable or using the new operator to create an object, or let's say an integer or something. But we're going to look at this in this tutorial at how to allocate a whole load of memory all at once. So we've seen before that you can do stuff like this. By the way, I've got an animal class here, and for this tutorial the relevant bits of this are that we've got a constructor and destructor that just have couts in them so that we know when they're running. We've also got a private instance string name and a set name method, so an instance variable there called name. So we've seen that you can do stuff like this. We can do animal, let's say pointer p animal equals new animal, and later on if you do that with new, you have to remember to call delete on the pointer later on to free the memory. So if we run this now, we're going to get animal created and destructor called, so that's coming from the constructor and destructor, which is here. We can also do similar stuff even with primitive types, like for example int pointer p int equals new int, like that, and again we need to do delete p int. So that would give us a single integer that we can set the value of, for example by saying p int equals 8, and we could do cout thing pointed to by p int, like that. Let's just run that. So you can use new on basically any type at all. What we can also do though is we can also allocate entire arrays of primitive types or of objects. Let's take a look at objects first. So this is creating one animal, so it's allocating the memory for that animal object, and it's also actually instantiating an object. Like we could allocate enough memory for this animal object, but not actually put anything in that memory, not actually have an object in there. And this is doing both of those things. It's actually allocating memory enough to put this animal object in, and it's also instantiating an object in that memory. So we can use array brackets with new like this. So we can say new animal. We can put array brackets after it and put in the number of animals that we want to create. Let's say 10. And if we use these square brackets after the type here, after new, to say that we want a certain number of these objects, or it could also be a primitive type here, like int or double, we must remember when we delete the memory, when we free the memory by calling delete on the pointer, we need to put square brackets also after delete and before the pointer, like that. And this tells C++ that we're not just deleting one instance of the object that the pointer points at, we're going to free up a whole load of memory that it's pointing at. So a whole load of memory blocks of this size. So if you have square brackets there, you're going to need them here as well. Although these don't have to have any number in them. But this says how many of these objects you actually want to create memory for, allocate memory for, and instantiate in that memory space. So let's run this now, and we get 10 animals created, and then when we call delete, we'll get 10 lots of destructor called down here. So we can also do this with primitive types, and it's particularly common to use char, because if we say char pointer p, let's say just pmem for memory, equals new char and then square brackets, because char is a single byte, we can allocate a specific number of bytes, let's say 1,000, and then we must remember of course to do delete on this as well, so delete pmem, like that. So this also works, and it allocates 1,000 bytes, and we can use this with any type, int, double, absolutely anything that we like. So if we actually do this with animal here, of course, then we could move this pointer around in that space to access different animals. And there are various ways of doing that. We could just use a for loop or something. We could do stuff like p animal, could use array syntax and say p animal 5. So that's actually the 6th animal in the sequence. We've got 10 starting at 0. P animal 5 dot speak, let's say. And that is a method that I created here that outputs the name of the animal. So we probably should set it as well. Let's do that. So let's say p animal 5 dot set name George. Let's check that that works. So this is just working with the 6th animal in the array, which is at index 5. And there we get, here we've got my name is George. So I'm going to leave it there for this tutorial, and I'm going to give you actually a little exercise to do. The exercise is to allocate, create a class, much like animal here, something similar to that has an instance variable of type string, and a set method that lets you set that string, and also some method that lets you output that instance variable as well. So create a class like that, call it person or animal or whatever you like, could be anything. And then allocate an array of 26 of them, and then for each object in that array, which you've allocated using new, so I'm calling this an array because it's like an array. So for each object in that memory that you've allocated, all 26 of them, set the name to be a string that contains a single letter of the alphabet going from A through to Z, so like the American or English alphabet, and then call the method on it, whatever you've created that outputs that string. So you're going to have 26 animals allocated with the new operator, and you're going to set the name on each, so they're going to be called A, B, C, D, E, and so on through to Z. And you're going to also output that name with some method you've added to your class to output the string instance variable. I'll just make a couple of little remarks. I'll just give you a couple of tips on how to do that. One thing that I want to show you is that if you want to set a string to a single character, we can do it like this. We can say, here's our character, we'll just call it C, equals A, let's say. Then we can say string, let's call it name. And we can use a form of the constructor that accepts that character, but it's actually got a parameter before that, and the first parameter tells you how many of these characters to put in the string. So if we set this to 1, that's saying create a string that has 1 character in it, and that character will be A. If we put 10 there, the string would have 10 A's in it, one after the other. Let's just output that and check that it works. So let's save that and run it. And yeah, I actually meant to use this. Yeah, we've got the A there, but I actually meant to use this char that I declared there. Let's do that. So we can see we've got a string and it's got just the letter A in it. If we put like 5 in there, for example, we'd have a string that consisted of 5 A's. Let's run this, and there we've got our string with 5 A's in it. And if you create a char like this, remember a char is basically an integer type, so you can actually increment it like this. If you increment a char, or you could add some number to it for that matter, if we run this, because we started with A, we've now got B. That's because wherever A is in the table of ASCII characters, so no matter what this number is equivalent to, if we increment it, we're going to get the next character in the set, which is B. So using those two facts, you can create strings with all the letters of the alphabet and use them to set the names of your objects. So have a go at that. And I'm not going to give you the solution to this, but if you do get stuck anywhere, then absolutely the thing to do is Google for every little thing that you get stuck on. Try to build it up step by step, and absolutely don't be afraid to Google for example code for what you want to do. And the better you get with using Google, the better programmer you'll be, because you'll see more and more techniques, more and more ways of doing things, and gradually you'll gradually remember those, and you'll gain flexibility with using different techniques. So Googling is a great thing to do whenever you get stuck. Okay, so until next time, happy coding.